working in this online environment. So I'm really pleased to welcome Jack Stilgoe. He's an associate professor in science and technology studies at University College London, our sister group there, where he's researching the governance of emerging technologies. And Jack, as many of you should know, but some of you may not know, played a major role in picking up the concept of responsible research and innovation and thinking how it might be applied in the practices of research and innovation. And he was one of the key players behind the framework supported by the Engineering and Physical Science Research Council and UCL more generally on responsible innovation. And he's also doing work on driverless cars, and he's led an ESRC project called Driverless Futures, which looks at the politics of self-driving cars, and he's recently published a book, Who's Driving Innovation. So we were very pleased that he could be one of our early speakers in this seminar series, and we're delighted to hear from you. Over to you, Jack.
Thanks so much, Robin, and it's great to be here. I've had various conversations with various people within the sort of TAS ecosystem, but needless to say, it's new and it's big, and I guess it's growing. So I'm very keen to keep talking to as many of you as possible. And one of the interesting things I think about it, and Robin will no doubt agree, is that it is a sort of interdisciplinary experiment as well, which means that social scientists like Robin and me get to play alongside scientists and engineers. If I share my screen like that, I assume, unless I hear from you, that you can all see my my slides. So this is what I would like to talk about today, asking this question: how can we know a self-driving car is safe? And the joke about social scientists is that the response to almost any question is, well, it depends. And in this case, it depends on a few things. So it depends on what we think we mean by know, right? And I'm going to be asking about, you know, what it means to know with confidence and what it means to know in a sort of credible and trustworthy way. So there's the sense of sort of public knowledge rather than just knowledge that satisfies an engineer or a risk assessor. It depends what we mean by a self-driving car. And I'll be talking about how we understand the technological system that we're problematizing here. Are we just thinking about the vehicle, or are we thinking about the system in which the vehicle is moving? And it depends what we mean by safe. How safe is safe enough? It's an age-old engineering question, but I think the case study of the self-driving car allows us to get some new insights into that one. Just to say a little bit about my project. So we're into the third year of the Driverless Futures project, which is looking to anticipate the potential politics of self-driving cars and ask what would good governance mean for that technology. So here are some of the other things that we'll be looking at in the project. And if people want maybe in the questions to follow up on some of these, I can. We have papers coming out on all of these, or papers that have already been published. The paper that I'm talking about today is this one, which has just been published in the Journal of Ethics and Information Technology. So you can get the full argument there if you want. Now, oh, hang on, just getting a bit of an echo. Maybe somebody's. Oh, that's gone. So as long as everybody's muted, that should be fine. Let me start then with a story. So when we think about the safety of self-driving cars, you know, one of the sort of public touch points immediately might be one of the very high-profile crashes that have taken place involving machines that are partly automated. This is a photo that was sent to me by another science and technology studies colleague. This is a guy, Jameson Wetmore, at Arizona State University, which has been home to some of the most high-profile testing of self-driving car technology. And he took this photo because it was, pretty much on his doorstep, a memorial to a woman, Elaine Hertzberg, who was the first bystander to be killed by a self-driving car collision, which happened in March a couple of years ago. And needless to say, this story is, the details of this story are complicated ones, and it generates questions about responsibility. In effect, who is to blame for this tragedy in the interplay of machines, infrastructures, policies, and individuals. I've written a bit about this crash, in particular with reference to a report that came from the National Transportation Safety Board, who are a very interesting governance organization, because they have this emphasis on what I would call social learning, right? Then rather than asking who's to blame in terms of legal liability, their emphasis is on learning so that tragedies don't get repeated. And they have this strap line: anybody's accident is everybody's accident. And that applies in the domain where they do most of their high stakes accident investigation, which is air travel, right? In which competition on safety has been downplayed while social learning has been emphasized. So the question that I have is what might we learn from the death of Elaine Hertzberg? Now, at one level it was a technological failure, right? It was a failure of artificial intelligence to do what was hoped, right? Let's just say it in those most general terms. A system that was designed to recognize and classify objects failed to do that job. It failed to predict the path of this object because it misclassified Elaine Hertzberg initially as an unknown object, and then a vehicle, and then a bicycle. Now, as well as being a failure of technology, it was also an organizational failure in many ways. So the woman that was supposed to be legally responsible for the vehicle was not looking at the road at the time of the crash. She has since been accused, but as of a couple of weeks ago, her lawyers have actually taken this to appeal, right? So even though the case was sort of resolved to the satisfaction of the police, it still could throw up some new legal questions. One of the questions about the failure, though, of this so-called safety driver would be why she was given insufficient training, why she was insufficiently qualified, why there was only one person in the car rather than two, right? And it says something about what social scientists might call safety culture as well. And at the time, Uber was at the center of a lot of organizational controversies. The then chief executive was accused of running a rather toxic work environment, and the safety culture, according to some investigative reporters, filtered right down to the level of the decisions that engineers made about how to tune their system, and things like the employment of safety drivers. But it was also a policy failure, because the reason Uber were there testing their technology in Phoenix was that the governor had, in effect, invited them to Arizona in order to test their technology with very few other requirements. So we start to see a sort of the nesting of layers around the technology that mean that the question of safety assurance, risk assessment is far from straightforward. Now let's just zoom back and do a bit of the theory here. So since the 1970s, I guess, engineers have taken extremely seriously the question of variable social assessments of risk, right? An appreciation expressed here by Chauncey Starr that different modes of technological intervention will be assessed differently by members of the public, depending on, for example, whether members of the public feel that they are in control of a particular system, whether failures of the technology result in catastrophic risks. And then, you know, in popular terms, we can explain this as the difference between fear of flying and fear of driving, right? We know that flying is, on average, maybe 2 orders of magnitude safer than driving, and yet we express more concerns typically in the popular imagination about flying. We tend not to appraise the risks of driving, whether that's our own driving or others driving, accurately. And so we've seen a lot of social scientists investigate the psychology that underpins risk perception, for example. We've also seen social scientists explore the cultural underpinnings of social assessments of risk that might be not just to do with a sort of individualized risk assessment, but might be to do with a cultural sense of fairness and justice that might influence regulation down the track. We've also had social scientists exploring the difficulty, not just in engineering terms, but also in terms of public credibility, with assessing risk before a technology is released into the world. So this is Alvin Weinberg, himself a Cold War engineer, talking about the impossibility of doing an accurate ex-ante risk calculation of nuclear power stations, in effect, because no data was available. So even though we might pretend to ourselves that we are able to assess the risks of technologies probabilistically, in many cases, technology should perhaps more accurately be framed as a form of social experiment, where risk assessments are a sort of continuing project of social learning. Now, when it comes to self-driving cars, what do we see? Well, one of the things that my team and I have been doing is interviewing a lot of self-driving car developers, stakeholders, policymakers, to try to get a feel for what the emerging governance regimes might look like. And I guess the first story that we would extract from those interviews is a narrative that says, you know, that's optimistic about the technology, that says because the technology of the self-driving car purports to solve a safety problem, right, a problem of human error that leads to, you know, I mean, upwards of 1 million deaths per year worldwide on the roads, then the safety benefits are self-evident, and then the project is one of, in effect, reassuring people that the technology is doing what it purports to do. So rather than a project of safety assurance, we've characterized it as a project of reassurance, saying, if you like, we are continuing to make technological progress towards this obvious safety goal, and therefore the numbers should speak for themselves. And you see this in the way that self-driving car developers have incentivized and discussed the progress of their technologies. The example that I like to refer to comes from this company. This is May Mobility, the chief executive of May Mobility, Edwin Olson, who says, you know, how might we discuss self-driving car progress? Well, one way would be to talk in terms of a Moore's law, right? Moore's law, which for a social scientist is a sort of classic naturalizing of technological progress. It's not a law, it's a target, but it is used to justify the idea that technological development is inevitable and accelerating, even in areas, you know, well outside the original domain of Moore's law, being semiconductors. Right, and here the sort of simple sketch that Olson is drawing is one in which you could sort of imagine that human beings, you know, in effect, have a catastrophic disengagement, so a failure at a certain fixed level, and that self-driving vehicles are approaching that level exponentially. Therefore, by a certain year, we will be able to demonstrate clear exceeding of human performance, justifying not just rapid innovation in the technology, but also deregulation. So that's the sort of simple view of the safety by numbers story. Talking to engineers, you know, it becomes quickly apparent that almost nobody in private really believes that story, because it's so easy to start to unpick it. Not least because, you know, if you think about a number that says we have traveled X million miles without a serious incident, or we have traveled X billion miles with only a few failures, right? One of the immediate questions that might be asked is, well, which miles? So, you know, innovators in the US know how very different roads are. When Google's engineers were given a challenge to, and this was, you know, a challenge with a financial bonus attached, to drive 101,000 miles, self-driving miles, round about 2009-10. The Google chief execs at the time recognized that not all miles were equal, and so 1,000 of those miles they added as, you know, particularly hard routes, if you like, one of which was this road, which some of you will know in San Francisco, Lombard Street, known as the crookedest street in the world, right, which is clearly a bigger challenge than the sorts of very straight, well-protected roads that are characteristic of a place like Phoenix, Arizona. Another interviewee talked about how, you know, this idea of perfection, right, that we might aim for if we want to convince the public of safety, would always be out of reach, right? And talked about, you know, the non-linearity of progress towards this goal. So we have a number of problems with a safety in numbers type story, and again, talking to engineers, you know, engineers would seek to, at least in private, hang on to an alternative story, which I've called safety by design, which is, and this is especially, you know, those engineers who might self-identify as working in safety assurance. They might have experience with prior systems. They might have more experience with hardware than with software. For them, a self-driving vehicle, a robot, a heavy robot traveling at speed in an open, uncontrolled environment, represents a safety problem rather than just an a priori safety solution. And the sort of issues that they are likely to talk about include those of human-machine interaction, the risks that are produced by systems and systems of systems, rather than just, you know, the autonomous object, as it were. Questions of redundancy, what it means to build in layers of redundancy when you are, for example, dependent on an AI at the heart of the system. Questions of interpretability within that AI. And then, if you like, the driving test question, how you would go about testing the technology to the satisfaction not just of the engineers that built it, but some external observer, and how you would combine the uses of simulation and real world testing. Let me just dig into a few of those points in detail, because I think it's worth just spending a bit of time on them. The first one, this question of operational design domains. So even though the big story of the self-driving vehicle is one of autonomy, right, and this is, you know, what you might hear coming from somebody like Elon Musk, for example, is, you know, that they are selling a self-driving car that is able to drive it, or will be able to drive itself in the near future, always and everywhere, right? Actually, in conversations, it becomes clear that the operational design domain will be increasingly important in the characterization of these systems. And the operational design domain would include not just what the road looks like and what infrastructures the vehicle can depend upon, but also what invisible infrastructures there are, like the high definition maps that self-driving car companies use in order to anticipate the world around them, but also types of weather. So, for example, Waymo in Phoenix, yes, they're testing a driverless system, but at the moment they're having to put their safety drivers back into the cars when the weather gets bad. Phoenix, Arizona, the weather is mostly good, but the Waymo system is not good in rain. And other more complex features of the operational design domain include things like other road users. So not just the actions of pedestrians, but also the road culture and the rules of the road. I would take to be not just those formal rules of the road, right? Thou shalt do this in this circumstance, but also all of those informal, unwritten rules of the road as well. So once we start to take this system of systems approach, the project of assurance looks much more complicated. And then we have a question that's familiar to, I'm sure, this audience, to do with the interpretability of AI systems. So, as Tesla have been allowing their customers to use autopilot, this sort of video has been has cropped up on YouTube as the particular, especially the sort of wonkish end of Tesla's clientele want to test out their system and observe what it can't do as well. And here is two examples of the misrecognition of traffic lights. In one case, looking at a truck carrying a load of traffic lights. In another, looking at the moon and thinking that it's a yellow traffic light. Right, and at one level, this is a sort of a failure of common sense that might be typical of any nascent AI system. But the interpretability question would be, well, do we understand why this is happening in a generalizable sense? So that we can understand more about the safety assurance of these systems, rather than just say, oh, here is another edge case to be ticked off. Right? What are the matters of process and principle that we can use to increase our social learning? Some of the interviewees that we spoke to problematized this issue in terms of safety culture. So not just about getting the numbers right and making sure that different disciplinary perspectives were involved, but also that risk was a function of the culture of organizations. So this interviewee, a safety engineer, was very critical of the arrival of tech companies into the world of automotive innovation and automotive regulation, that safety assurance just wasn't part of the culture of those organizations, and that this was a hard thing to just learn from first principles. So there was something about this sort of safety last approach, and the disciplines that were represented within these the upstarts, as this person would see them, into the field. At the moment, most of the governance of prototypical self-driving systems, at least in Europe, but in the US as well, in most cases, is sort of scaffolded by safety cases. So in other words, bottom-up statements of the safety of a prototype technology that justify, if nothing else, the testing of that technology. And these safety cases tend to be performative rather than prescriptive, in that companies are asked to demonstrate what they are doing rather than being told to do things in a certain way. And the scaffolding for those safety cases in most examples is the use of safety drivers. So a safety driver that legally takes responsibility for the vehicle. Now you can see the limits of that mode of governance when you look at a situation like Waymo, which removed the driver from its vehicles without much regulatory intervention. Right, so that currently would not be permitted under European regulations, but it tells you something about how de facto governance regimes, unless they are well thought through, can lead to actual governance regimes down the track. Now, one of the other things that we've been doing in our project is asking the public what they think about these things, and also in some cases asking our interviewees what they think about the public, if that makes sense. This interviewee had a very clear idea that there was an appropriate role for public opinion in this debate. And this interviewee had a very clear sense of what the public would be interested in. The evidence that we have taken from our experience with doing public dialogue suggests the opposite, that there is substantial public interest in processes of innovation, the view that says, trust me, I'm an expert, will not earn public credibility, and that if members of the public are asked, they will have their own questions. Just to give you a feel for what that sort of thing looks like. So one of the things we did for the British government 3 years ago was we ran the public dialogue on connected and autonomous vehicles, where we were asking people what they thought about hopes and fears for the technology and its appropriate governance. For the sake of this talk, and just so I can wrap up in a few minutes, let me just draw attention to some of what this public dialogue exercise said about safety. I should say, by the way, for anybody that doesn't know what public dialogue is as a process, what we had in this situation was about 150 members of the public in 5 locations over 3 days, spread over a month or so, with a mixture of group conversation, that's what's going on here, and talking to expert witnesses with materials provided by an external, materials agreed by an external body of stakeholders. So the views on safety, I think one of the most interesting findings from our public dialogue is that members of the public don't necessarily regard safety as a one-dimensional thing, right? So if engineers reach for metrics of safety that might be, for example, total number of deaths or maybe even near misses, right, with which to extract a risk assessment. Some of our participants in this public dialogue exercise would say, well, safety is also about personal security. So this particular an issue for the women that were in the public dialogue, right? They were thinking, well, how do I trust that I'm going to be safe if I'm getting into a vehicle that has no driver in it? Because a driver is more than just somebody who controls a vehicle of, say, a public transport system, right? So safety might be interpreted in very different ways by different people. There was a presumption that because we were talking about cars, right, and mobility, that there was already a strong regime in place because people knew how tightly regulated cars were, right? People know that when they get into a car or get onto the road, they are more regulated than in most parts of their lives. And so this presumption of strong regulation was allowed to frame quite a lot of the conversations. And in many cases, they were surprised to know that when it came to, for example, the the arrival of in effect an AI onto the road, the regulations for that were pretty sparse. Questions of risk were very closely related to questions of responsibility. The question of who's going to take responsibility when something goes wrong becomes a really important one really quickly, which means that the question how safe is safe enough, right, that became of interest to engineers gets reframed instead as a question of, well, safe enough for what? So the question of safety gets tied to the question of benefits. People wondered, well, who's going to benefit from this technology? Because it's a different thing, right? If a technology has clear, widespread benefits, then the societal acceptance of risk might be very different from if the technology is seen as just benefiting a small group of maybe rich consumers or people who already have lots of transport options, say in cities. Right, so that tying of risk to benefit provides a really complicated political challenge. Let me just end then with a reflection on what that might mean in terms of how we think about trust and trustworthy autonomous systems. So when we, academics, scientists, researchers talk about trust, it's often easy to forget that trust isn't something that we can build. Trust is a gift of the public, right? Trust is something that the public give, not something that engineers can prescribe, and that trust is not just about demonstrating adequate performance. So if a lot of the safety assurance debate on autonomous vehicles has been about showing that they can do what engineers expect that they'll be able to do, right, and measuring progress along that road, trust as a public concern is more complicated, more multi-dimensional than that. It's also about process. It's about the process by which these things work, which includes things like the interpretability of AI systems, and it's about the purposes of innovation. So for whom is this technology seen as being? Who are the imagined beneficiaries? And then in that case, trust becomes a far more complicated thing to have to explain. Right, I will end there. I look forward to any questions on any of that. If you want to pick me up and ask me to fill in on any of the details, please do. But I look forward to the discussion.
Thank you very much, Jack. Very interesting indeed. We've got two questions already posed. Alan, do you want to voice your question in the chat?
Yes, I'm very happy to do that. So one of the things we're interested in our node is UAVs rather than cars. So I wonder how much of your analysis and your conclusions do you think would map to related technologies like drones? Obviously, it's different in various ways, but I wonder if you can generalize.
So I think the first thing I would say is that context matters, right? I think that's one of the lessons, especially if you take this view of trust as something that's sort of embedded where the sense of imagined benefits is closely linked to a sense of how safe is safe enough, which for something like drones and UAVs, right, might be even harder because at least, on the road vehicles is a technology that is very much a part of everybody's lives. Mm-hmm. I mean, for UAVs, one example that I always come back to is when in New York in, I think it was the 1970s, they tried to establish a set of, in effect, private helicopters to do, to get around above the city. And when one of those helicopters crashed, right, the local government in New York rightly said, well, who's benefiting from this technology? If it's just benefiting a bunch of billionaires, then why should we continue to allow for its presence in our city, right? So that became a politically really important part of the context there. So I think specificity is important, but I think that's not to say that you can't learn across domains. And actually, a lot of so if you ask members of the public what they think about this technology, right, a lot of those opinions will be framed by opinions on earlier technologies, right? And a lot of the implications for governance might be hangovers from those earlier technologies. So, you know, this question of whether you evaluate a technology in terms of its outcomes or its processes, that was a hugely important part of the political debate about genetically modified crops, right? A completely different technological domain, but where, with a bit more anticipation of the social context of that technology, we might have been able to head off some of the most sort of polarized debate there. So that's I mean that's sort of an unhelpful social scientist answer, which is none and both. But hopefully it.
Oh, thanks. Yeah.
Stuart Anderson, you've posed a question about comparing transportation sectors. Do you want to just present that, and then a question about numbers as well, but maybe take them one after the other?
Okay, so you want me to do the second one first, Robin?
Yeah.
So I was wondering if you compared with other transportation sectors, you know, so, I mean, if you look at the standards for aviation, it's widely acknowledged that there's no sensible way of demonstrating the kind of evidence that they want. I guess full authority digital engine controllers, they were introduced in the early 1990s. Rolls-Royce didn't get evidence from actually real operational data until 20 years later that they achieved the standard that they were supposed to achieve. So there's it certainly is in lots of sectors, digital systems are introduced, but actually there's no evidence to show that they achieve, there's no strong evidence to show that they actually achieve what's required of them. So and I think pretty much that's what you're going to see here. Yeah, I mean the other thing. Okay, I've got a third question, but I'll frame that later.
Well, can I? It's a really interesting example. So while I know, you know, I know a bit about the sort of broad comparison that can be made with safety assurance in aviation, but that point about, you know, whether you can a priori come up with the numbers that are being demanded of you, or if those numbers might instead be thought of as a target that at least sort of trains the social experiment of technological development. I think that's really interesting. I mean, my sense is that one of the most important thing that standards can do, rather than being tick boxes, right, is actually to give innovators a target. And of course, there
was a huge transformation after Piper Alpha, where pre-Piper Alpha, pretty much everything was tick boxing. You know, you were told you had to do these things, and then post-Piper Alpha, the whole idea of goal setting in standards came in and actually pervaded the standard setting and influenced a lot. I mean, there are lots of sectors. I mean, so the fusing standard in 0055 in British military, it was, I think, the first to require formal proof. Because they wanted 100% possibility. I mean, and different sectors have taken different approaches. You know, so if you look at nuclear, for example, then they have a claim limit on any one mechanism, which forces lots of diversity. They have a claim limit of one failure in 10 to the 4, I think, demands. So I think there's a very interesting thing to look at different sectors and to see how they operate.
Yes. So yeah, I'm afraid I don't know about those particular examples. I'm just trying to desperately jot these things down so I can look them up myself. But so I think one important thing though that you raise is how very different the alternative governance regimes can be. Right. So for anybody that says, oh, well, inevitably, this is the right way to assess and to regulate, you can point to a diversity of approaches in different areas, all of which, you know, have strengths and limitations, and then we can have a sensible trade-off between them. I think there's a particular question that I have that other people might know about, which is the addition of, you know, variously opaque AI systems into these technologies. Does that change the debate fundamentally, or do we actually have experience that we can learn from in one of these domains where we can say, actually, no, we know how to deal with systems that are not fully interpretable, maybe not fully deterministic, and we can do that? Or do we just need to be honest about the fact that, you know, there will be failures, and set up systems, as we've done with aviation, that aim to credibly learn from those failures?
Well, that's a big question. I mean, one thing I would say, I mean, this kind of pushes on to my final question, which was, car manufacturers are learning a lot at the moment in any case. I mean, I was in a Volkswagen, I can't remember, an ID3 or something, in a tunnel in Berlin the other day, and it put the emergency braking, you know, the braking system that brakes when it sees an approaching vehicle.
Yeah.
And the reason was LiDAR reflections in the tunnel. Now, VW know that happens, yeah, but I don't know if they're collecting data. I don't know if that car actually collected data. But if all of the copies of new vehicles where you have vehicle assist features built in were actually collecting data, then you might have a very significant change on the way that you might make arguments. But I don't know the extent to which people are doing that. I mean, maybe some other people on the call might know. But I do think it's interesting, because it's definitely the case that we've got this whole panoply of driver assist features that are in place in modern cars. You know, if you drive an ID3, it just feels like driving, I mean, I have one, it just feels like driving a piece of software on wheels.
Yeah.
It doesn't really feel like an ordinary car at all. But I do think there's an opportunity to gather enormous amounts of data in terms of near misses, in terms of misinterpretation, and so on. But I don't know the extent to which that's being done. So,
I mean, one of my challenges back to the developers in this, because a lot of them talk about, you know, the technology as being an unparalleled opportunity to do that job of data collection and learning. Right. And so I think, you know, one role for government here is to say, well, OK, if we're learning, let's all learn together and work out where we can share, for example, pre-competitive data. So, you know, Tesla talk up the fact that having driven billions of miles now on autopilot, their driver, if you like, right, assuming that it is one learning object, has orders of magnitude more data than other companies. And the question is, well, you know, who's learning from that data and what are they allowed to learn? Is this just about making Tesla's systems safer, or is it about saying, actually, if we collectivize that learning, then you can imagine dramatic improvements in safety and efficiency? I mean, I would be surprised if VW wasn't doing that, you know, treating their cars as learning objects, because other ADAS systems are doing that.
Yeah, sure. I mean, I think, but it is an interesting. I mean, it's an interesting area that I think would benefit from looking at.
Yeah.
I mean, I think the other thing in automotive is the extent. Sorry, Robin, this is becoming a chat just between me and Jack, and then I'll shut up.
There's a big queue of people wanting to come in.
Right.
The most patient of those was Jane Fenn asking, have you read Automation Expectation Mismatch?
So yeah, I'm just reading Jane's question. Yeah, so this is it's a really interesting issue. This relates to one of the things that safety engineers, and in particular, you know, traffic psychologists point to is this question that in some ways is a familiar one from earlier automated systems, which is a problem of human machine interaction, right? And automation complacency is well known from aeroplane autopilots and other areas. It's taken rather a long time for self-driving car companies to take some of that stuff seriously, but well, actually, no, I mean, not completely, because Google talked about this quite a lot in the early days, when they were saying, in effect, we want to skip the middle step, right, without wishing to complicate this, the idea of partial automation, where, you know, humans and computers would share responsibility for driving, because that question, the question of the handover, was so problematic. Because people tend to trust automation too much, and then they become extremely bad at taking over from the system, and that's both a long-term skill detriment issue and a short-term one of concentration in the moment.
Excellent. So we've got Peter Davis and Habli Ibrahim. Peter first.
So thanks very much for your talk. I guess what I'm interested in is you talked a lot about gathering the data, you talk about these things, but the vocabulary you got there is the kind of learning that individual human beings do in relation to that. Surely one of the differences that you get here on automated systems is you have systemic failures that are coming out of these. So it's all very well, and this I know is one of the things that the insurance industry is extremely concerned about. They are perfectly happy with the idea of things that behave in the way that humans did, in that I've got one that turns out not to be a very good driver. What they are not able to insure is 40 million vehicles with an automated capability that fail simultaneously in the same way, because, for instance, you've updated with all of this learning. That aspect of the systemic is something that we've got to find a way to solve, and it's really not something that we've had to solve in the aircraft industry, because it's been so much smaller, so much more individualized, and it's so much more specific in what it's doing.
Yeah.
But my feeling is, if you can't start to find an answer to that, and some of the solutions you're suggesting are great, if you like, in smaller scale systems, but actually turn out to be the problem when you're talking about some of these much more connected and these much larger scale systems that we're looking at. So perhaps you'd like to comment on that and
yes,
help me out of my misunderstanding.
No, that's really interesting, Peter. Thank you. The questions of the differences in scale between air and road travel are really interesting in terms of how we think about modes of governance, licensing, right? I mean, it's, you know, it's sort of easy to imagine governance regimes for air travel, not just because there aren't very many of the objects, but also because there are pretty much two manufacturers that can be under very tight regulatory control, and so the assurance of those systems looks very, very different. The point that you make about systemic failures, I mean, so all I have observed is a sort of clear asymmetry on that point, which is that, you know, the companies developing the technology are very eager to say, because the whole fleet can learn as one, right? You can have gigantic improvements in safety, and, you know, in effect, using the idea of using a very anthropocentric view of learning, or starting with that and then saying, you know, when one learns it, they all learn it, in effect. And I guess what you're drawing attention to is the flip side of that, which is to say, you know, when there's one failure, there may be, you know, you're much more likely to get catastrophic failures, which changes, and it changes the risk assessment and changes the comparability of the risk situation, right? So if the sort of naive view of safety assurance is one in which you're saying there's an existing risk at the moment, which we all agree is a disaster, and it's this sort of nature of risk, right, which is the risk of road deaths, and then we have a hard to understand risk that may be, you know, more systemic, it may be more uncertain, it may be harder to get the data on. Can you compare those things together, or are they apples and oranges? And the incommensurability of those risk assessments, I think, could be one of the most problematic things there. And I think that's, you know, you're giving another really nice example of that, but I'm afraid I don't have much more to say on.
Okay, thank you.
Brahim?
Yeah, hello. So I'm from the University of York. So I mainly work on safety assurance for safety critical systems, initially with traditional domains and more recently with healthcare. I think the discussion is interesting, especially the last questions, because here we're talking about safety as rare but catastrophic events. And in particular, the ghost in the machine is of interest to us, which is the software, which is basically now the brain of the machine. And I think one of the early questions was about Rolls-Royce and engine controllers, and it is there where my career in safety started. But there we have to remember that we are talking about software in highly controlled domains, where Rolls-Royce will give you an answer to any question about any line of code within their software. So it's a tightly defined domain, highly controlled software. And yeah, definitely there, Rolls-Royce or Airbus or anyone else couldn't guarantee prior to deployment any of those astronomical figures. But what they can do is tell you that there are standards in the domain which were developed by industry, the experts who have been doing it. And it mainly hinges on the notion of safety integrity levels. In other words, the regulators, the engineers have agreed on what good enough looks like. And then they all work to that target. And they can do it because they have the experience with developing those systems. And therefore, they were able to come up with a consensus. The problem at the moment is that we don't have enough experiences with developing those systems. And therefore, in many cases, standards are about what we wish people can do and hope for the best versus what we did in other domains. So that's one thing. The other problem with the current technologies is that it's not incremental. We have a leap in change. In other words, the fact that the model is a black box, okay, is basically a huge leap from what was accepted. Like someone mentioned IEC 61508, where the standard explicitly says don't use AI. So in other words, up to 5 years ago, the safety critical industry is saying that AI is dangerous. Don't even think about it. And it is there, I think, where we have this gap between the two different communities. And back to the numbers as the last comment. The problem with software is it's so fluid and fragile. In other words, you change one variable, you have completely different behavior, and therefore all of the miles you've collected might be invalid. And that's where you have a difference between software and other technologies like drugs or bridges, where probability and other things are continuous. In software, it is deterministic and discrete. And that's another thing where still, like, state of the art hasn't caught up with this. Yet everyone is still talking about those numbers.
That's really interesting, Brahim. Thank you. And I think, you know, it's one of those perspectives that suggests to me quite how big the gap is between the ideal and the current situation, right? This mode of de facto governance at the moment, because, you know, it's easy to forget that, you know, without much approval, people are testing this technology in public without, I mean, maybe they've got the permission from some people, but they certainly haven't got the permission from the other people that are on the roads with them, right? And if you're thinking about, you know, safety, integrity levels and agreement on what good enough looks like, I don't think we're even close to having a publicly credible sense of what that level should be, right?
Yes.
Right. And so when you're, and it's sort of easy to come up with principles that say, you know, we should be really skeptical of, or even we should ban the use of non-deterministic or opaque systems, right? But these things are being used, right?
Exactly.
And that might shock us as people used to looking at transport technologies, but if you look in, say, the world of digital regulation and look at, how Amazon and Facebook use data and how far that is from the regulatory ideal as well, that's become the norm. So, there's multiple clashes of cultures here.
Yes. One last thing to say, given the question you asked about how safe is safe enough, is that within current practice with non-AI based systems, it's a scale. You have 1 to 5 in terms of levels, and level 1 is easy to define. Level 5 is easy, but the overwhelming majority of the applications in automotive in particular are in between. And defining a scale is very, very, very hard, because unsafe, we know sort of what it looks like. Perfect safety, we know what it is, but define what's in the middle. That's where I think, you spent 7 years as part of a committee. I was part of the committee updating D178C, which is the main software guidance in the aerospace domain. It took 7 years on people to agree. And for you as a sociologist, the dynamics is interesting, because sometimes the regulators or certain regulators, like the American side, would abstain, the European side would vote for it, meaning that certain bits won't be endorsed by one side of the world, but not the other.
Yeah.
So yeah, that's why I'm saying it's a long process. But I think your work and the work of others is interesting, because it's shedding light on the need for transparency on how those standards emerge.
Thank you.
We're about to reach our hour, but there's been a very interesting discussion between Jane Fenn with Stuart, and I wonder, Jane, if you want to. It's beyond the size of the page for me to read it. So, Jane, can you just summarise that discussion?
Yeah, no problem. So I started off by saying that I'm actually on the committee now for the DEFSTAN 00055 and 00056, which is the safety and the software safety standards, because somebody was talking about it earlier. So there's a really interesting interplay going on between goal-based regulation and prescriptive regulation. So it used to be that both the civil and military aerospace domains used prescriptive regulation. So when somebody talked earlier about formal proof, that was when it was a prescriptive version in the military domain. And civil aerospace has stayed with prescriptive. Military aerospace has gone to goal-based regulation since about 2008-ish, somewhere around there. And the competency requirements for using goal-based regulations are significantly higher than for prescriptive-based regulation. So that's caused some issues in people's level of competency to deal with that. So some of the way that that's being dealt with is that the goal-based regulation have said, well, you can use prescriptive standards to comply with our regulation. So in the military, we're now allowed to use, the ARPs and DO178 that Ibrahim mentioned earlier, to comply with the military standards, as long as we apply what they call a military delta on top of the civil standards. So you've now got the military regulators saying, well, I just want to use what the civil world use. And the civil world are saying, we've got as far as it is reasonable to get in terms of civil aircraft safety with a prescriptive approach to regulation. We need to go to goal-based. So we've got the people who have goal-based wanting to use prescriptive-based, and the people who use the prescriptive wanting goal-based regulation. So make of that what you will. It's certainly there are very different approaches, but if that's a story you want to look more into, that might be a rich source of research information for you.
Yes, it sounds absolutely fascinating, right? and I guess is, on both sides you have people realizing the limitations of that approach, and ultimately you have to have you have to understand the trade-offs and make a choice. I guess I would say as a social scientist, those choices and standards committees in general, tend to be highly technocratic ones, and I would say that in lots of these cases there's a legitimate public interest in these debates as well, and so the opportunity to and benefits of seeking to democratize them could be really important, because ultimately these standards will enter the world, they will shape innovation, and when disasters happen they will need to be defended. And doing that just after the fact is never ideal. that's fascinating, Jane. Thank you.
Yeah, so I think that there was other bits in there. I don't know how much time you've got. So that there was things about you talking about the how the standards will deal with it. DEFSAN 00055 has just been updated to incorporate a section about AI, also about cybersecurity, because somebody was asking about that as well. And what's been done there is to say we understand how, from our normal way of doing system safety engineering, we understand what the dependency is on the AI and the software implementing the AI. We just don't understand how to show that the AI meets that requirement yet. So I think a lot of our process around understanding obligations and demands, and then you get into all sorts of interesting things like people want to do performance metrics around AI just based on performance against that goal, but you get asymmetric safety requirements on AI that say we don't care if it fails in this way, but we do care if it fails in a different way, which is completely blows the minds of AI technologists. So there's kind of interesting stuff there. And somebody asked about cybersecurity. I think that's something that we definitely need to look at with AI. We don't know how to do it properly with standard safety engineering yet, let alone safety engineering and security engineering with AI in the mix. But we are thinking about it because we've got the IET producing guidance at the moment. I'm on the committee for that as well. So I'll shut up now so other people might get a chance.
Jane, I think we need to get you to give a seminar to us fairly soon. I'm joking. I think that's really interesting. Look, we've run over time. There's no machine that says we have to switch off now. So if people want to continue to discuss, if Jack's willing to hang around now, we could have
I can hang around, yeah,
informal discussion. But I think we should say at least that's been really, really interesting. And it's been productive of a very important dialogue, which I hope we can continue through the trusted autonomous system nodes, not just Edinburgh's, but more generally. But can we clap? I think I can find my button for electronic clapping here, because that was very, very interesting indeed. Thank you, Jack.
Thank you all. Thank you for having me. Yeah, and if anybody does want to keep on talking.
As I say, I've put in the chat Suzanne Perry's email if people want to have access to the recording in due course.
So Jack, this is Stuart again.
Hi, Stuart.
I just wanted to follow up on what Jane said, because I do think looking at safety and security is really interesting. I mean, she said even without AI, safety engineers find it quite challenging to take into account security issues when you're looking at safety cases. And I mean, my question on that was really, I mean, security has this rather open-ended thing, you know, in the sense that security risks are well, because they're adversarial, you know, people are just making up new stuff all the time in some sense, and so it has a little bit of the characteristic of an open-ended system like driving, you know, where people are coming up with ever more novel ways of doing dangerous things on roads, and so I thought that maybe looking at some of the literature around, you know, how to incorporate security issues into safety critical, without thinking about AI, would actually raise quite a lot of the problems that safety engineers encounter in trying to deal with that kind of open-ended, that rather open world risk environment. Yeah. Because most of the time, I mean, a lot of the time, what safety engineers tend to do is to control the world in some way or another, you know. So you mentioned it, you know, things like geofencing and so on, where you basically you eliminate certain sorts of categories of risk from what you're looking at. And so I thought that might be an interesting one to look at.
That sounds really interesting. Yeah, and I think the open-endedness of it is exactly right, because, you know, at one level it's very easy to characterize driving as an engineering task, right, and to relate a set of inputs to a set of actions.
Yeah.
But we all know from being on the road the the breadth of the horizon of possibilities there.
Yeah.
And our regulatory systems and modes of licensing are set up to deal with that, which is one reason why. So I'm fascinated by the highway code, for example, that the highway code is actually rather unprescriptive. It was written in the 1930s as a guide for, I forget what Herbert Morrison called it. He said a code of good manners, right? So it puts a lot into common sense to deal with that open-endedness.
Actually, I've forgotten the specific reference now, but I think there is a kind of psychology paper somewhere which says it's impossible to drive safely,
right?
Because and it's a kind of processing constraint argument. It just says you cannot possibly process all of the things you're supposed to process if you're following the highway code.
Right. Yeah. Well, if you do find, I would love to, because
okay. I mean, it's an ancient thing. I mean, I remember it from my youth. I mean, I'll try and find it.
No, I'd love to. But yeah, that point about that you make about closing the world.
Mm-hmm.
I think it's inevitable that we will see, after the sort of initial phase of demonstration and prototyping, once self-driving developers feel like they've got a relatively convincing story, right? They will start to identify and then close worlds in order to make them amenable to their innovation. I mean, you're seeing it already, right? There was a story about how they want to build a self-driving only lane between Ann Arbor and Detroit in Michigan. As a prototype environment for this, and then basically you're turning the system into something like the Docklands Light Railway, right?
But I think there's a long history of stuff about forming convoys on motorways and so on, and saying that essentially the way we should use motorways is to have convoys of vehicles driving down instrumented roads and so on. I mean, from even from last century, I think there's quite a lot of work in that area.
Yeah, well, this is so I didn't have time to do it now, but the history of self-driving is a fascinating one, because actually the sort of the recent version of that story is all about AI, but the decades longer version of that history is about instrumented roads. It's about smart roads, not smart cars. But the AI story has been so seductive since the DARPA Grand Challenges that it's been allowed to obscure that history.
I mean, the other one, I had another question actually, which has to do with the economics of the car business. And they're incredibly cost sensitive. Yeah. And I don't think car manufacturers really take into account just how much the processor is going to cost that they're going to need to do some of this stuff, and I do think that there is an issue about the economics of cars. A couple of cents on the cost of something can make the difference between whether you use it or not.
Right.
And so I do think that framing all of this in something which is not, say, like aviation, which is if you like, it's a very small business actually, the number of aircraft that get built a year, but each one of them is quite high value. But we're talking about a mass-produced product where, the production engineering of the thing is actually quite an important thing, and how to get the costs down in order that you can compete. And it is, it's a highly competitive environment, and I don't know what influence that's going to have in the long run on how these things are done. But it's clear that at the moment, some of the things that are being done they're doable, but they're just doable within the constraints of what the car manufacturers are prepared to pay for the hardware and software that goes in.
Oh yeah, I think the economics of it. This is one of many issues that has just been intentionally postponed because it's too hard to imagine an economic. The lazy version of the economics here is that because you're removing the driver, an Uber type robo-taxi system that loses 75% of its cost will therefore inevitably be economic. But actually, once you account for all the actual costs of getting these systems to work, right? At the moment, it's being presented as these are just investment costs up front to get to a system that then becomes infinitely scalable, right? And it's quite easy to see the problems with that with that story. And some people have started to sketch out the economics of possible self-driving models, and it's really hard to see how any of it makes sense. Because it's not just about the cost sensitivity of the hardware. It's about, if one bit of the system doesn't do exactly what you'd like it to, then you need to, scaffold that with, whether those are remote drivers who need to come out and save a car that's got into trouble, or remote operators, or something else. It starts to look really complicated. So, yeah, God knows.
Yeah. So I do think there's an interesting economics thing, because I guess the other thing is that there are quite big promises in terms of the impacts on the need for new roads, and the idea that you won't have any on-street parking anymore, and so on and so on. The idea of greatly increasing road capacities within cities, for example.
Yeah.
Using autonomous vehicles is it changes the economic argument, actually, if there's a way of transferring those savings into the production of the vehicles and so on. So so I do think I think there's a very interesting economic analysis still to be done I haven't really come across any good.
Yeah, there's a bit. I can send you a couple of papers that have started to at least ask the question, but most of it is very, the problem with most of that analysis is that it does take the technology for granted. Right? So it says, okay, imagine a world in which you can just take drivers out. What does that look like? And then it sort of, anticipates various second order effects about what that will do to cities and all the rest of it. But as soon as you start to, play around with some of the assumptions behind the technology, then it falls apart pretty quickly.
Yeah.
Jack, I was interested. You talked about the cultures of safety in Google, but I just wondered if you looked at all about the cultures of cars. And there was really interesting work that Knut Sørensen did in Trondheim about the car and its environment. I have 100 copies of the book in my office, if I'm ever allowed to revisit there. I can send it to you. And he points out, the cars are called Mustang, yes, because they're linked to this American idea of the open frontier.
Yeah.
And how that impacts. But you said you're driving a piece of software. And I'm not.
No, I said that, Robin.
Well, the machine said. How people's aesthetic experience and their sense of control or loss of control. If we're having experiences like the Dreamliner pilots who seem not to enjoy the plane suddenly stalling, is that something that you've attended to? Is there anything about the cultural perceptions of users of these vehicles?
Yes. So one of the funnest sources for this is actually there's a magnificent angry book by Matt Crawford. Do you know him? A sort of conservative pop philosopher guy. I'll put it in the chat here because I did a review of it for The Guardian. And his argument, it's a really interesting one. It's an annoying book, but the challenge is, right, if you're talking about autonomous systems, at some point they will need to deal with autonomous people. And when it comes to cultures of automobility, you have this weird situation where even though we are more tightly regulated than in any part of our lives, partly as a product of intentional advertising, but we are sold this dream that it is the greatest possible expression of our freedom, being in a car. So the idea of the autonomous driving individual, and you can imagine situations in which, in a world of self-driving where death rates have gone down because of automation, that the right to drive is being defended like the right to bear arms. Right, and people object to having to take their Mustang just to a racetrack in order to drive it. Right, so you can, you know, and if you're one of the tech utopians, you can say, oh well, people don't care about that anymore, right? Young people don't want to learn to drive anymore. Sports cars are a thing of the past, right? People regard the motor car as in increasingly instrumental terms and all the rest of it. But you know, it's
if you go around Birmingham and look at what people have done to the size of the wheels on their cars,
absolutely
no longer believe that. And
there was a fascinating exhibition. The V&A, the Victoria and Albert Museum in here in London, did an amazing exhibition on cars and car culture a couple of years ago, where they had, you know, all of the various cultural expressions of automobility, and it's a very good note of caution for anybody that you know. But again, you know, the utopians would say, oh well, people seem quite happy with Uber, right? So actually, most people don't care.
But as you say, that's not part of the equation. I mean, it's very interesting. You're talking about social learning process, which we normally think of as social learning as what happens when you bring things into the wild, and then a whole range of voices can be expressed. But this is a social learning process taking place in a very privileged, protected space, which may not align well with the intended future world. So it's a little bit like a living lab in which only the engineers and lawyers are allowed to take part.
Yeah, that's really interesting.
I see. I mean, maybe this is that the case? You see, I mean, because I think that, I mean, if you look at modern cars, they have quite a lot of stuff that's going to be in autonomous driving vehicles. You know, and you get in and you can spend quite a long time configuring your car these days. Yeah, in terms of the software, and that determines the behavior. And I do think there's quite a lot of kind of, if you like, debate going on, Robin, around exactly the way that you configure your car and how it is that, how much autonomy you want the car to have. You know, because, you know, you have lane keeping, you have adaptive cruise control, you have automated parking, you have, I mean, there's a whole slew of stuff that if you put it together, actually, most of what's in the car would, I mean, provided that, I mean, if these things are enough to build an autonomous vehicle. I mean, the hardware is enough, yeah, because your car will take control of your steering wheel if you let it, yeah. I mean, generally speaking, it will also tell you to keep your hands on the wheel. But so I do think there's a kind of debate going on, and it's a kind of debate about what kind of combination of these things work for people, and how do they drive in that fashion. And so there's a whole culture going on around modern cars. I mean, this is something that I've encountered relatively recently, because I used to drive old cars all the time, but I've been driving electric vehicles recently. And what that means is that actually you tend rather more to get things that have all of these packages. And people are prepared to pay for them, you know. So I mean, if you look, people can test the market. They can say, well, do you want the lane keeping package? Do you want the adaptive cruise control? Do you want this? Do you want that?
Well, I think that's the sort of, you know, the easiest trajectory to imagine for this technology is that very boring one, right? In which they become not at all disruptive. They just become the technology enables more comfort for high-end cars and then trickles down, right? But you know, you do still have a situation where you can pay Tesla an additional $10,000 to buy the full self-driving hardware, where you're buying a lie, right? Yeah. And at some point you take you sort of should, I think, take the lie seriously, or at least ask the question, right? And people are doing those experiments with their Teslas on technologies that don't do what they purport to do.
No, I know, and of course there are lots of people who drive Teslas who will not do that. Actually, they don't take the myth, but what they do is use it extensively as well. And I do think that, and in a way, I mean, I don't know if it's still working, but there was all of this stuff about risk homeostasis that came out around automatic braking, where you saw a dip in accidents when automatic braking systems were introduced, and then the number of accidents just went back up again because people will travel closer to the thing in front of them. And I mean, I don't know, adaptive cruise, people probably, I don't know, they probably find a way to get around that. But I do think that there are kind of, there's a process of acculturation of these things going on, and it gets built into the way that people drive.
Now, guys, I'm afraid I have to now duck out.
Right.
I've got to go and pick up the kids, but that was a real pleasure. Thank you for having me.
Thanks very much. Very interesting.
And, we look forward to further discussions. It's been very interesting indeed.
Well, yeah, I'm sure that we will have other opportunities too, but yeah, I really appreciated it.
Thanks very much.